So let's work on the problem from homework 3.3, problem number 11. And this is not going to be a simple question. I understand you may feel frustrated during the process of calculation. It's understandable. So you should be able to at least find 50% of the answers accurately, very, very efficiently. The other half, it takes some time to digest, and if you go with synthetic division, it might take a long time. So I'm telling you another way to work around it, but bottom line, you should understand how to solve this type of problem in general. So what I have here is a sixth order polynomial where there are two roots that's given to you directly, and I'm asking you to find all other roots. So first thing, it's order 6 polynomial, so technically I should be having 6 different roots. They may not be distinct, so some of them might be repeating one another, but bottom line, the multiplicity of all the zeros of your function putting together is supposed to be 6. So because I know negative 5 minus 8i is a root based on what we said, in class, the conjugate must also be a root. Similar idea, positive 7 minus 2i will lead to 7 plus 2i to be another root of your polynomial. So out of the 6 root, or 6 zeros of your polynomial, you have 4 of them already. So the question is about how to find the other 2. In order to find the other 2 polynomial, you know yourself must be looking for a quadratic function to factor. In order to identify what exactly is a quadratic function, you want to take your original polynomial divided by x minus x minus x minus x minus each of your root here. So like I said, to divide it by x minus this negative 5 minus 8i, it's going to be worked out perfectly with synthetic division, but it might take forever. So the whole reason conjugate solutions appear in pairs because there's some kind of beautiful cancellation going on. So let me just show you very quickly what exactly that cancellation is going to look like. So hopefully when we do a division, if I do them in pairs, it's going to be very simple to calculate. And here we go. So we have x plus 5 plus 8i, and then I have x plus 5 minus 8i. So one way to look at the problem is you can FOIL things out. So you have x, you have 5x, you have negative 8x. So we have x squared, I have 5x, I have negative 8ix, and keep going. You have 5x, you have 5, you have negative 40i, and the other way around, you have positive 8ix, you have positive 40i, you have negative 64i squared, which by the way is negative 1. So you end up with x squared, you end up with 10x. Those two terms cancel out. Those two terms cancel out. You have plus 25 minus 64 times negative 1. In other words, it's x squared plus 10x plus 25 plus 64. And if you are very comfortable with the basic factorization, it's actually x plus 5 squared plus 8 squared. That's exactly how you come up with the answer, and that's exactly why we want to group things up. It's the first half squared times this number squared. That's exactly the beauty of having conjugate numbers because it makes the calculation extremely easy. So to summarize, this is x squared plus 10x and plus 89. So the other piece, if you have x minus 7 minus 2i times x minus 7 plus 2i, it's going to be equivalent to x minus 7 plus 2i times x minus 7 minus 2i. And according to my previous discussion, if you were to simplify this out, it's going to be equivalent to that, hence x squared minus 14x plus 49 plus 4, which is supposed to be x squared minus 14x plus 53. So you find two factors of your polynomial already, both are quadratic. So if you order order 6 divided by 2 quadratic functions, it's going to downgrade the order by 2 twice, which means you are going to end up with something of order 2, which is exactly what you are looking for. So let's go ahead and do the calculation. And you know already, synthetic division no longer works because synthetic division only works for a division of linear structure. So what you're going to end up with is you might want to use what's the so-called long division. But of course, I understand we said you don't have to know what exactly is long division to success in this class. So one thing you could have done is you could find a website, search for polynomial division solver, and you can just go to the website and then have your problem pasted in there and let it do the division for you. Or you can go over this with me once just to carry out the division. So let's just try to do the division. Let's try to divide it by x to the 6th, the whole function, divided by x squared minus 14x plus 53. So in order to cancel the leading term, you must have x to the 4th multiplied by that, it's x to the 6th, minus 14x to the 5th, plus 53x to the 4th. If you find the difference of those two terms, this gives you 0. That gives you positive 10x to the 5th. This gives you negative 67x to the 4th, minus 652x cubed. And then you find that you need 10x cubed here. So you end up with 10x to the 5th, minus 140, or x to the 4th, plus 530x cubed. And then you keep going with your calculation. So the next thing you want to have is what exactly is the difference of negative 67 minus 140, which is plus 140. So you have 73x to the 4th left. The other part is gives you 1182x cubed. You borrow your term down here plus 4685x squared. So you need to have a 73x squared top in the front. So this is what you end up with. And 73 times negative 14. 73 times negative 14 is going to be 1022, which is negative. So 1022x cubed. And then you have your 73 times 53. So you end up with 3869. So it is plus, so it's plus 3869x squared. So if you were to find the difference with your first row minus your second row, what you are going to end up with is negative 160x cubed. And then what you have, if you were to subtract those two numbers, which is 816x squared, you borrow that term down here, which is 11456x. So your leading term need to be negative 160, and you have an x here. So you end up with negative 160x cubed, and the minus minus, which is a plus, and you have your 60 times, 160 times 14, so it's 6416. So you end up with negative positive 2240x squared, and then you end up with 160 times 53. So 160 times 53, which is 8480. So it's minus 8480x. So if you were to find the difference, the leading term that you are going to end up with is going to be negative 1424x squared. Of course, you can finish the calculation, but I know this is a factor of my polynomial. So the difference of the two pieces must lead to a remainder of 0. So what I'm going to end up with is minus 1424. So this is my quotient that I'm going to come up with divided by the first factor. So what I'm trying to tell you is that x to the 4th plus 10x cubed plus 73x squared minus 160x minus 1424 must be identical to the two unknown factors multiplied by the other factor which you've already identified earlier, which is factor of your original polynomial, which was x squared plus 10x plus 89. So in order to find the multiplication of the two other factors, it's exactly the same procedure you would have done for the multiple synthetic division. So you are just going to go ahead and say, hey, why don't I just take this and do my division? So you are going to carry this divided by x squared plus 10x plus 89. So you have x squared here, which is x to the 4th plus 10x cubed plus 89x squared. You realize the difference is 0, difference is 0. So the difference here is negative 16x squared minus 160 minus 1424. So you have nothing coming up here. This is directly minus 16. And the rest part, if you were to carry out the calculation, you will realize it's simple repetition of what's above. When you multiply your function by negative 16, the remainder is 0. So what you end up with is your original function is identical to x squared minus 14 here, whose factors can be easily identified as x plus 4 and x minus 4, which leads to the 0, 4, and negative 4. Okay, so this is exactly how you're going to work this out. You go ahead from the two given complex numbers, you find two other roots to make the calculation easy. You are originally supposed to divide all the synthetic division 4 times for 4 factors. But to make my life easy, I group two of them together each time, so my numbers are easy to carry out in terms of division calculation. 4 of them are grouped into 2 quadratic functions. You do long division twice to reduce your highest order 6. 2 divided by square, you end up with x to the 4. 2 divided by another x squared term, you end up with x squared. So by doing this 2 division twice, of course, like I said, you could take advantage of this website and let it help you to carry out the division for you. So you end up with x squared minus 16 as what's left as your quotient. So you can factor this and find your last 2 zeros extremely easily. If you can't do that, a quadratic formula would help you to resolve the concern as well.